The spontaneous redox reaction between zinc metal and copper-2 ion can be harnessed in a voltaic cell to generate electricity. The cell consists of two half-cell compartments connected by an external circuit. Oxidation takes place in the anode compartment, in which a zinc electrode dips into a zinc nitrate solution. Electrons leave this compartment, travel through the external circuit, and enter the cathode compartment. There, reduction takes place at a copper electrode dipping into a copper nitrate solution. A salt bridge maintains charge neutrality in the two compartments. Let's zoom into the atomic scale and see how this cell operates. Here, at the anode, the site of oxidation, zinc atoms in the metal bar are in contact with the surrounding electrolyte solution. Each atom loses 2 electrons and becomes a zinc ion, which diffuses into the solution. The electrons given up enter the bar and join the flow of electrons up toward the external circuit. They travel through the wire and flow into the cathode, the site of reduction. When a copper-2 ion in the cathode solution makes contact with the copper electrode, it gains 2 electrons and is reduced to a copper atom, which deposits on the bar. Therefore, as the cell runs, the zinc anode becomes lighter and the copper cathode heavier. Now let's close in to see the role of the salt bridge. The non-reactive sodium and nitrate ions of the salt bridge prevent the buildup of charge that would occur as zinc ions enter the anode solution and copper-2 ions leave the cathode solution. Such a charge buildup would halt cell operation. In the anode compartment, nitrate ions leave the salt bridge to balance the gain of positive charge as zinc ions enter the solution. Some zinc ions also enter the salt bridge. In the cathode compartment, sodium ions leave the salt bridge and nitrate ions enter it to balance the loss of positive charge as copper-2 ions leave the solution and are reduced at the cathode. Thus, charge flows continually as the cell operates. Negative charge in the form of electrons flows from the anode through the external circuit to the cathode. As negative charge in the form of anions flows from the cathode compartment through the salt bridge to the anode compartment, positive charge in the form of cations flows in the opposite direction. The oxidation of zinc metal in the anode combines with the reduction of copper-2 ion in the cathode to give the overall cell reaction. Under standard conditions, this cell generates 1.10 volts of electricity.